Going to start now section 3.4. It's about the slope-intercept form of the equation of a line. So remember, we are trying to learn how to plot linear equations because we want to solve linear inequalities before finishing this chapter. So there are many ways that we can express a linear equation. There are many forms. So we have three main forms to express a linear equation. So we have this form ax plus by equals c, where you see the two variables are on the left-hand side, the two variable terms, and on the left-hand side, and the constant term is on the right-hand side. The name for this equation is the standard form. So anytime that you see the standard form, this is the kind of equation that they are talking about. What is the best way to graph this equation? We're going to use the intercept. Remember, the very small t-table with 0, 0 in the diagonal. We use that method, very simple, to obtain the graph of the standard form of the equation of a line. There is another form, very common. This is y equals mx plus b. Y is on the left-hand side. This equation is solved for y. Then you have the variable x, the term containing the variable x on the right, and also the constant term. And the name of this form is the slope-intercept form. So we're going to use a method that we're going to cover today. We're going to use the slope and the y-intercept method to plot the line. And there is another third way to express the equation of a line. This is the way you use, right? Y minus y1 equals m times x minus x1, where x1 and y1 are the coordinates of a point. So this is going to be the point slope method because you're using a point and also the slope. So the point and slope form. And we're going to use the same method that we use for this one to get the graph for this line. So essentially what we're going to learn, because this is going to be covered on section 3.5, we're going to convert this form into this one. So, and we're going to cover in this section now this form here. So this form is very common in some fields of science like statistics, psychology, history, sociology, and this form is very common in engineering and related disciplines. So today, now we're going to learn about the slope-intercept form. So we're going to learn about y equals mx plus b. So we already know information about this equation. This is going to be the slope of the equation, m, the coefficient. So the coefficient of x is going to be the slope. And b with sign is going to be the y-intercept. So it's going to be the y-coordinate of the y-intercept. So you express the y-intercept as 0, b. So the y-coordinate of the point where the y-intercept is has coordinates 0, b. So x usually in some of the fields that I mentioned before is known as the independent variable. The independent variable, or the explanatory variable. In statistics, we use the explanatory variable, and y is going to be the dependent variable, so meaning that y depends on x, the value of y depends on the value of x, or in statistics, we use the name response. So that's a very important equation. So the first thing is that we need to be able to identify the parts, those features of the equation when you see any equation written in this form. So we're going to start with example 1. So let me just right here, example 1. Example 1 is on page 246. The directions are that we're going to find the slope and the y-intercept of the line with the given equation. So our first case is just y equals 2x minus 4. So how are we going to find the slope and the y-intercept? We're going to do it by inspection. So we're going to look at the equation. So first, we're going to have the slope-intercept form written in the way that we wrote it in the table. Then we're going to write the equation that is given, and then we're going to compare one equation with the other. So you can see here the equal sign. So align the equations, and you can see here the independent variable x. So from just checking these two equations, you can see that in between of these two circles, you have m and you have 2, so you can say that m equals 2. And also the remaining part on the right-hand side, you can see b equals negative 4. So that's the way that we proceed by finding the slope and the y-intercept, just by inspecting, examining the given equation. So it's not hard. You just need to be careful that you compare term by term the given equation with the form y equals mx plus b. So the second case is y equals 1/2 of x plus 2. So I'm going to do the same thing. I'm going to do it now over here. I'm going to write my formula, the form, the slope-intercept form. I'm going to write now the equation. I'm going to align everything. So especially I'm trying to align x, I'm trying to align the equal sign. So in that way, I'm going to be able to check the information that is giving me this equation. So m equals 1/2 and b equals 2. So the slope is 1/2. The y-intercept is 2. If you need the point, the y-intercept, the coordinates, remember that you need to write 0, b. So in this case, it's going to be 0, -4. That's the y-intercept. And in this case, 0b is 0, 2. So that's the point where the y-intercept is. So now the last problem is part C. So the equation that is given is 5x plus 2y equals 4. So now you can see that this is not the standard, this is not the slope-intercept form, this is the standard. So this is the standard form. So we need to transform the standard form. We need to rewrite it. We need to rewrite it in the slope-intercept form. How? You need to solve for y in the way that we learned. We were working with formulas on chapter 1. So I need y to be isolated. So I'm going to write here phi x plus y equals 4. So I'm going to isolate the y term first, the y term, because it might be that you have a coefficient here. So the first thing is you isolate the y term. So how do you do that? You're going to subtract phi x from both sides of the equation. So you end up with only y on the left-hand side, and then you just write this horizontally, writing first the x term and then the constant term. So this is negative 5x and this is positive 4. So this is now the equation in the slope-intercept form. So now we can proceed and find the slope and the y-intercept. So I'm going to write here y equals minus 5x, trying to align the x's and the equal signs. So I have here the equal signs, I have x and x. So you can now, by inspection, you can find that m equals negative 5 and b equals 4. So the corresponding y-intercept is at 0, 4. So I'm doing this step because we're going to need this point later to work on the last method that we're going to learn about graphing linear equations. So now I'm going to give you a lot of problems to solve because it's very important that you can get the point, you can get the slope-intercept form. This is the form that is going to be very useful in our course. And if you take statistics or any other field, psychology, you're going to need to deal with a lot with this equation. So let's work on the exercises now. I'm going to give you the assignment. So you're going to work on page 252. So this is going to be 3.4 exercise set on page 252. So the directions are the same. You're going to find the slope and the y-intercept of the line with a given equation. So there are a lot of exercises. Let's see. You're going to work on number 2, y equals 9x plus 4. Number 4 is y equals 4x minus 2. Number 6, y equals negative 3 over 4 x plus 6. Number 8, y equals 10x. Number 10, y equals 7. Number 12, y equals 5 minus x. So that's the first set. In this set, you only need to compare the equation with y equals mx plus b and match m and b with their corresponding values. But there is another set of problems where you need to rearrange the equation in the form that you're going to be able to see the slope-intercept form. So in these equations, you're going to be given in some cases, the standard form. So negative 9x plus y equals 5. So you need to arrange this to get y on the left-hand side only. The same thing with number 16. You have x plus y equals 8. Then you have 18 ax plus y equals 0. Number 20, 3y equals negative 9x. You only need to divide by 3 here and you get the slope-intercept form. 22 is going to be 2x plus 9y equals 0. 24 is going to be 4x plus 3y equals 4. And finally, 26, you're going to need 2.5x minus 2y equals 10. So at least work the problems on the first column. But if you work all of them, that would be better. Problem 8, you're going to find many times this kind of problem. So I'm going to give you a clue. When you have y equals 10x, you can see here that you have the y term, you have the x term, but you don't have the constant term. So you need to rewrite this in this way. So you're going to write y equals 10x plus 0. In that way, you can compare the equation with y equals mx plus b. The same thing with number 10. So number 10 is just y equals 7. So now you are missing the x term. So that means that the coefficient of x is 0. So you can rewrite this as 0x. That's the reason there is no x here, plus 7. So I think with these two clues, you're going to be able to solve all those problems and find the corresponding slope, y-intercept. So I'm going to give you 10 minutes to solve these problems, and especially the ones that are marked with the stars. So solve these problems and start having your work ready to be to be prepared into a PDF file. So, okay, start working on that. So now we're gonna learn the third method to obtain the graph of a linear equation. So the previous methods were the point plotting method. Remember, that's the general method, regardless the form of the equation. And then we learn about the method to plot the standard form of the linear equation, which is just the equation where the variables are on the left-hand side, both x and y, and you have the constant term on the right-hand side. And we used intercepts. So we created a small t-table with zeros in the diagonal to find the intercepts, both the x-intercept and the y-intercept. So if you don't remember how to do it, just check page 226 to remember that. So now we're going to cover another method, the last method that is going to be very useful. And this is very very important method when you have the linear equation in the slope-intercept form, which is y equals mx plus b. And we're going to use the slope and the y-intercept. So this method is described in your book on page 247. So the steps, what are the steps? The first step is just finding the slope and the y-intercept. So finding m and b. So we learned to do that just a moment ago. So then we're going to rewrite the slope as a fraction. So if the slope is just an integer, you just divide by 1, and then you have a fraction. If you have the slope already in a fraction form, that's perfect. Then we're going to start our plot. We're going to plot first the y-intercept. Remember, y-intercept, the coordinates are always 0, b. So you need this value here, b. So that is going to be your first point. It's a point that is on the y-axis. That is going to be the intersection of the line with the y-axis. So that is going to be our starting point. So we're going to do some jumping. So we're going to start jumping through the plane. So you're going to jump through the Cartesian coordinate system to find points. We're going to find points by using m, the slope, as the jumping rule. So how is this going to work? So remember, we need the slope written as a fraction because the numerator is going to indicate my vertical jump, and the denominator is going to indicate the size of my horizontal jump. So with this information, anytime that you finish these two jumps, you get a new point for your line. So you're going to see this now. I'm going to solve one problem by using this new method. So this is going to be example number 2 on page 247. So we're going to graph the line whose equation is y equals 4x minus 3. So the first thing is we need to find m and b. So we need to write our formula for the line, for the equation of the line in the slope intercept form. Then we're gonna write the equation of the line that we want to graph, and then we're gonna compare this term by term. So we're gonna be able to find the slope is gonna be 4, and the y-coordinate of the y-intercept is gonna be -3. So the next step, we're gonna write m as a fraction. So m is gonna be just 4/1. Then our next step is gonna start, we're gonna plot the y-intercept, which is just 0, b. So in this case, it's going to be 0, -3. And that is going to be my starting point. Then my jumping recipe. We're going to use the jumping recipe. It's just m is 4/1. So I'm going to jump 4 units up, and I'm going to jump 1 unit right. Okay, so we're gonna need our grid paper. This is gonna be 4A for your notes. So now I'm going to start. I need my y-intercept is at 0, -3, and my recipe is just for 1. So up and right. Up and right. So let's look for the intercept. The intercept is 0, -3, so 0 is my origin. So 1, 2, 3. So that is my starting point. Then I'm going to start with my recipe. So I have here 4 units up, starting from here. So 1, 2, 3, 4, and 1 unit right. So that's my point now, my new point. I can continue with the recipe. So 4 units up, 1, 2, 3, 4, and 1 unit right, and so on. So then you just use your ruler and get the line. So that is gonna be the equation for this line. So usually we can indicate with an arrow that this equation is y equals 4x minus 3 in this way. So that's the equation for this line. So now we're going to work one more example. We have two more examples, and then I'm going to give you work to do. So let's go on the next example. So this is going to be example 3 on page 240A. So now we're going to graph the line whose equation is y equals 2/3 of x plus 2. So let's start again. We're going to find M and B. So we write the general, we write the point, we write the slope-intercept form, and we write also the given equation trying to align the equal sign and the x's. So we're going to be able to see the slope and the slope in this case is 2/3, and the y coordinate over the y-intercept is just 2. So then we need the m as a fraction. In this case, it's already a fraction. And we need the coordinates of the starting point, which is the y-intercept, is going to be 0, b. So in this case, it's 0, 2. And finally, my recipe to jump is 2/3. So is 2 units up, 3 units right. 3 units right. So let's work on this by using, again, our grid here. So now we have a point at 0, 2, and we have the slope 2/3, so up and right because both are positive. So we're going to start at 0, 2, 0, 1, 2. So now my starting point is here. And I'm going to go 2 up and 3 right. 1, 2, 3. 2 up and 3 right. 1, 2, 3. And you should get the points aligned. So now I'm going to do another line here. Another line right here that I have the equation y equals 2/3 of x plus 2. That's the equation for that line. So I think I'm going to solve one more problem for you, and then you're going to work on these problems. So let me see. Now example 4. Example 4 on page 249. So we're going to graph the linear equation 2x plus 5y equals 0 using the slope and Y-intercept. So although this equation can be graphed by using the intercepts, we're going to use the method that we are learning now. So we need to find M and B first. So to do that, we need to solve for Y first. So we need to solve for Y to find the slope-intercept form. So first, we isolate the Y term. So that's the first thing that we do. We isolate the Y term. How? We're going to subtract 2x from both sides of the equation. So I'm going to get 5y equals negative 2x. Then we isolate y. So we isolate the variable. How? We need to divide by 5 both sides. So we end up with y equals negative 2 over 5x. So this is my equation. So now let's continue in another page. So I have now, I need to find M and B. I haven't finished the first part. So I have y equals mx plus b. That's the way I need to find M and B. So I'm going to write the equation I just obtained, negative 2 over 5x. So, and you don't have the rest, you just write 0. So I have the equal signs aligned, I have the x's aligned. So now I can see that m equals negative 2 over 5 and b equals 0. So what is the next step now? We already have m as a fraction. We have the intersection point to be 0, 0. So in my recipe is going to be m equals negative 2 over 5. How do we write the recipe when you have a negative? Here, I mentioned that we can write the negative sign in the numerator and the positive then it's going to be the denominator. Or you can do it on the other way. You let the numerator to be positive, then the negative is going to be the denominator. So you have two different recipes and you're going to get the same result. So in this case, you have 2 units down and 5 units right, or you have 2 units up because that's the vertical shift and 5 units left. So the result is going to be the same either if you use either the first recipe or the second one, you're going to get the same result. So let's try this. So I'm going to have now 5a here. So let's work on this. So I have 0, 0 now is the starting point, 0, 0. And the slope is negative 2 over 5. So the slope is negative 2 over 5. So this is down and right. So let's start at 0, 0. 0, 0 is here. So I need to go 2 units down and 5 units right. 1, 2, 3, 4, 5. So that's a point. Then again, 2 units down and 5 right. So 1, 2, 3, 4, 5 is going to be around here. But you can use the other way, the other recipe where you have 2 up and 5 left. So now starting again at the intersection, the Y-intercept, 2 up, 1, 2, 5 left. 1, 2, 3, 4, 5. 2 up and 5 left. 1, 2, 3, 4, 5. So all these points should be aligned. So, and they are. So you're gonna see that your recipe to jump throughout the plane, it works very well. So this is the equation aligned with equation 2x plus 5y. This is 2x plus 5y equals 0. So that's the equation of this line. So that's example. That's example 4. So now I'm going to give you an assignment for you to practice this. But before that, I'm going to explain how you can switch the recipe. So if you have a recipe, for example, you have 2 up and 5 down, you can switch the directions, both directions, and you're gonna get the same recipe. So you can switch up to down. I'm sorry, this is 5 right. And you can switch right to left, and you can get the same result. So this is a different, this is not the one, this is 2 up and 5 right. This is a positive slope. So this is 2 over 5, so up and right, and this is equivalent to -2 over -5. That's what I'm trying to say, that this is the case that we didn't cover here. But what I'm saying is that if you switch both the directions, you're gonna get the same recipe. So 2 down became 2 up, 5 right became 5 left, and we get the same recipe. Now when both are positive, so 2 up and 5 right can become into 2 down and 5 left, and you're gonna get the same result. So you're gonna get a positive slope. So you go up and right, and this is the same as going down and left. So, okay, you're gonna work now. This is better if you practice. So this is gonna be 3.4 exercise set on page 252. So you're gonna graph 5 equations. So we have 28 is just y equals 3x plus 1. Then 32 is y equals 1/3 of x plus 2. Then you have 36 is y equals -2/3 of x plus 4. Then 40 is just 2x plus y equals 0. And 44 is 3x plus y equals 4. So we're on these 5 exercises. Get your 5 plots, take screenshots, and then you're gonna send me those when we finish the lecture. I'm going to give you 15 more minutes for you to work on these 5 graphs. We're gonna start now section 3.5. It's about the point slope form of the equation of a line. This section starts on page 255. So that's the third way that we're gonna have for the form of an equation over the line. So the form is this: y minus y1 equals m times x minus x1. So you can express the equation of a line in this form if you know the slope and if you know a point. Most of the times you're gonna know 2 points. So if you know 2 points, you need to compute the slope first. So to compute the slope, you know the formula is gonna be just the difference of the y's divided by the difference of the x's. Then we're gonna be able to write the equation in the point slope form because you're gonna have now m, and you use one of the points to complete the equation. Then to be able to obtain the graph or for other purposes or other possible computations, we're going to apply the distributive property here. So you're going to multiply m by x and then by x1. So you apply the distributive property and then you solve for y. And in that way, you're going to obtain the slope-intercept form. So you're going to apply the distributive property to obtain the slope-intercept form. So you need to solve for y. So I'm going to solve a couple of problems, and with that we're going to be ready to work on linear inequalities in 2 variables. So I'm going to solve example 1. Example 1 on this section is on page 256. So the problems that we're going to write: the point slope form and the slope intercept form of the equation of the line, of the equation of the line with a slope 4, with a slope 4 that passes the point -1,3. So we know the slope and we know a point. So in this case, it's not hard. You just know that the slope is 4 and you know that the line passes through this point. So you just need to label the coordinates. Remember, that's one of the steps that we need to do when you need to either compute the slope or, in this case, to write the point slope form. So the point slope form is just y minus y1 equals m that multiplies x minus x1. So we're gonna do the substitution. We're gonna replace m with 4, and we're gonna replace x1 and y1 with their corresponding value. So I have y minus, and remember, this is the minus that comes from the formula, and y1 is just 3, so no problem. If you have -3, then you need to write another minus here. Then this is equal to m, which is 4, then x minus from the formula, and minus from the x1 coordinate. So I have x minus minus 1. So we simplify this. So we have 1 minus 3 equals 4 that multiplies x plus 1. So this is the point slope form. So that's the first part, the point slope form. The point slope form. Now to find the other one, we need to apply the distributive properties. So we're gonna multiply the slope and the terms that are inside of the parentheses. So this is going to be y minus 3 equals 4 times x is 4x plus 4 times 1 is just 4. Then we isolate. So first here we apply the distributive property, and then we isolate the variable y. So in this case, to isolate y, you just need to add 3 on both sides of the equation. You're gonna get y equals 4x plus 7. And that's the slope intercept form. That's the other form that we were required to find. So this is the slope intercept form. So that's the other form that we needed to find. Now that you have the equation in this form, then you can plot it. You just have your slope written as a fraction, so it's going to be 4/1. That is going to be your jumping recipe. You're going to start at point 0,7, which is the y-intercept, and then you're going to jump 4 units up, 1 unit right, and so on. Or you can invert the jumping recipe, so you're going to jump 4 units down and 1 unit left with the same result. So that's example 1. Now I'm going to solve one more example. And possibly you're going to have some work to do. So let's see. This is going to be example 2 on page 257. So a line passes through the points 4, -3 and -2,6. Find the equation of the line. So we're going to start by labeling the coordinates. We need to label the coordinates. So we have 4, -3, -2,6. So this is going to be x1, y1, x2, y2. Then we need to find the slope. So this is going to be y2 minus y1 over x2 minus x1. So we use parentheses. We start with y2, 6. Then the minus from the formula. And then y1 is -3, so another minus here, -3. Then x2 is -2, minus from the formula, and then 4. So this is going to be 6 plus 3 over -2, -4. So we add these two quantities, you're going to get 9. And then you add these two quantities, you're going to get 6, but they are negative. And then you can simplify this fraction by dividing by 3 both the numerator and the denominator. So you're going to get 3 over 2 negative. The slope is negative because positive divided by negative is negative. You can put the negative on the top or on the bottom. It doesn't matter. So now the next step, we're going to get just the point slope form. So the point slope form is just y minus y1 equals m times x minus x1. So y minus from the formula, then y1 is -3, then equals -3 over 2 is the slope that multiplies x minus from the formula, and 4, that's x1. So now we just simplify this. We're going to get y plus 3 equals negative 3 over 2 times x minus 4. And this is the point slope form. Now we're going to find the slope intercept form by applying the distributive property here. So I have y plus 3 equals negative 3 over 2 x minus 4. So we're going to apply the distributive property. So we're going to get y plus 3 equals negative 3 over 2x. Then negative times negative is going to be positive. Then we have 3 times 4 over 2. Then we simplify this fraction. So we have y plus 3 equals negative 3 over 2x. 3 times 4 is going to be 12 divided by 2 is going to be 6. Then the final step is solving for y. So to isolate y, we need to remove this positive 3 with a negative 3 here. So we're going to get y equals negative 3 over 2x plus 3. And that is going to be the slope intercept form. So now you're going to work just 3 exercises. So this is on 3.5 exercise set on page 260. So you're going to find the point slope and the slope intercept forms. So the problems that you're going to solve are problem 16. So it's a line passing through 3,5 and 8,15. Then we have 24 is another line passing through -2, -5, and 6, -5. And finally, problem 20 is another line passing through -2, -4, and 1, -1. So you're going to work on these 3 problems. This is important. You need to work on that. So I'm going to give you 15 more minutes, and then we're going to continue with the last section corresponding to this chapter. We're going to finish this chapter by working on section 3.6 about linear inequalities in 2 variables. We're going to use all our knowledge about graphing linear equations to find the solution of linear inequalities. The only way for us to find the solution of linear inequalities in 2 variables is just by graphing. There is no other method. There is not an analytical method. We need to use a graph to find the solution of a linear inequality in 2 variables. So I'm just writing here the steps that we're going to follow to obtain the graph of a linear inequality in 2 variables. So these are the steps. We're going to find first the boundary of the solution region. So the boundary is going to be a line. So we're going to write the linear equation that results of replacing the inequality symbol with an equal sign. So if you do that, your inequality becomes just a linear equation. That linear equation is going to be the boundary. Then we need to find the type of boundary, and we need to plot the boundary. So if you remember from the previous chapters, when you have the less than or greater than symbols, you have open boundaries. So in the case that, in this case that we are working with two variables, our boundary is a line. So if you have an open boundary, the line is going to be drawn by using a dashed line. So that's something like this. So this is going to be an open boundary. Use a line, a dashed line is going to be an open boundary. If you have the equal sign embedded into the inequality symbol, then you have a closed boundary, and you need to draw a solid line. So that is going to be the difference. So this is equivalent to the open or the empty dot when we had an open boundary on the number line, and this is equivalent to the filled dot when we have the closed boundary on the number line. But now we are working with two variables, so we are working on a plane, we are working on the Cartesian coordinate system. Then once you find the boundary, you're going to have two regions. So the boundary divides the Cartesian coordinate system in two parts. You need to test a point to see which of the two regions, which of the two parts in the plane is the solution region. So you're going to pick any point. For simplicity, we use the point 0, 0, the origin, to evaluate the inequality. If you get a true statement, then that means that the origin is inside of the solution region. If you get false, then that means that the origin is outside of the solution region. The solution is presented by shading the area where you got the true statement. So when you, the area that is the one that is the solution region. So you're going to use this testing to shade the region. For example, if 0, 0 is inside, then you shade the area where 0, 0 is. If you get false, then you shade the other area, the one that doesn't contain 0, 0. So I'm going to work the first example first to test points, because again, when we solve an inequality, we're going to have our plane divided in two parts. Let's say that this is the boundary, then the solution region is either this or this, because the plane is divided in two parts. So the same thing here. So we have our Cartesian coordinate system, and let's say that now we have this solid line as the boundary. This is a closed boundary. This is an open boundary. But anytime that you have a boundary, a line, you have two regions. One region on one side of the line, the other region on the other side of the line. So we need to know which of the two regions is the solution. So we're going to test points. So usually we test the origin. So if the origin, when you evaluate the inequality for the origin, you get a true statement, that means that this is the solution region. If you get a false statement, that means the other part is the solution region. So let's work first on testing points, and then we're going to solve a problem completely. So this is about testing points to see if they satisfy the inequality. So we're going to start with example 1. Example 1 is on page 263, and the directions are this. So determine whether each order pair is a solution of the inequality, and the inequality is 2x minus 3y greater than or equal to 6. So that's the inequality. Then we have the first set of points. We have 0, 0, because this is the testing that we're going to perform most of the time. So we're going to test whether 0, 0 is a solution for this inequality. So we're going to evaluate the inequality 2x minus 3y greater than 6 for x equals 0 and y equals 0. So you only need to replace x with 0 and y with 0. So we get 2 times 0 minus 3 times 0 greater than or equal to 6. So this is 0 greater than or equal to 6. So is 0 greater than 6? No. So this is false. So that means that 0, 0 is not inside of the solution region. So it's not a solution. In other words, it's not a solution, so it's not inside of the solution region, because now we have an entire region to explore. So the next case is now the point with coordinates 3, -1. So we want to know whether 3, -1 is inside of the solution region of this inequality. So we're going to evaluate 2x minus 3y greater than or equal to 6 for x. Now x equals 3 and y equals -1. So that means I'm going to replace x with 3, y with -1. So 2 times 3 minus 3 times -1 should be greater than 6. Let's see if that's true. So 2 times 3 is going to be 6. And negative times negative is going to be positive 3 greater than 6. So 9 is greater than or equal to 6. This is true. So that means that the point 3, -1 is inside of the solution region. So it's a solution of the inequality. It's inside of the solution region, and because it's inside of the solution region, that means that this is a solution, one of the infinite solutions of this inequality. So now we're going to solve a full problem. So we're going to find the solution of an inequality, a linear inequality, in 2 variables. So we're going to work example 2 on page 265. So we're going to graph 3x minus 5y less than 15 and find the solution region. So we're going to work this step by step. So first step, we need to find the boundary of the solution region. So we're going to write the left-hand side of the inequality, then we're going to use an equal sign, and then the right-hand side of the inequality. So what we are doing here is that we are replacing the inequality symbol with the equal sign. So this is the equation of the line. So this is the boundary. So this is the boundary line. This is the boundary line. And now you just check that this symbol indicates that this is an open boundary. So we're going to use a dash line to indicate that boundary. So now we need to plot the boundary. We need to plot the boundary. So in other words, we need to plot this line, 3x minus 5y equals 15 on the Cartesian coordinate system. So this is, now you are free to use the method that you like the most to plot your lines. I recommend in this case, because this is the standard form, that we use the intercepts, the method using intercepts to get the line. So we just need to find the intercepts. So we're gonna find the values for this as multi-table. So in the first case, when x equals 0, so I'm just going to cover, I'm going to hide the x term. I'm going to write negative 5y equals 15. So if x equals 0, I'm just going to find negative 5y equals 15. So you divide by negative 5 both sides of this equation. So you're going to find y equals negative 3. So that's what we're going to write here, negative 3. Then if y equals 0, so now we're going to cover the y term, and we're going to read 3x equals 15. So you can read it. So 3x equals 15. We divide by 3 both sides. So we're going to get x equals 5. So we're going to write 5 here for the x-intercept. So now we are going to be able to draw the boundary line, because we know the intercepts. So the next step is just finding whether 0, 0 is part of the solution. So let's do that. We're gonna test. We're gonna test 0, 0 to see whether that's part of the solution. So we're gonna evaluate the inequality. The inequality is 3x minus 5y less than 15 for x equals 0 and y equals 0. So we're going to replace x with 0 and y with 0 too. So we're going to get 3 times 0 minus 5 times 0 less than 15. Then we see that you get 0 minus 0 less than 15, so 0 less than 15. Is this true? Yeah, this is true. So that means that 0, 0 is inside of the solution region. So we're going to shade the region where 0, 0 is. If you get false, then you're going to shade the other region. So now we have all the information that we need to solve a problem. So I'm going to do a graph here. So this is my Cartesian coordinate system. So I note that the intercepts of the boundary line are 0, -3, and 5, 0. So 0, -3, -1, -2, -3. So that's the y-intercept, and 5, 0, 1, 2, 3, 4, 5, 0. So this is -3. This is 5. So you're gonna draw up a dashed line here. So that's the boundary of the solution region. And we found that 0, 0 is inside, so 0, 0 is here. So it's inside. So it's in. I can write out. If this is out, then you highlight this region. So that means that we need to shade this region here. So you can use any color if you have colors. So this is the solution region. Everything over here is the solution region. Very easy to find the solution for a linear inequality in two variables. And the dashed line means that any point on top of this line are not, any point is not part of the solution region. Okay, so this is the solution region. And also we need to indicate that this is a line that goes to infinity. So this is the boundary line. So this is a boundary with equation 3x minus 5y equals 15. That's the equation of the boundary. That's the equation of the boundary line. And since this is the solution region, you can use right here 3x minus 5y less than 15. So everything in this area satisfies any point here, any point. You can check any point here. That point is going to satisfy this linear inequality. So now you're going to go on one problem. And you're going to send me your solution. So this is going to be 3.6 exercise set on page, let me see that page. So this is page 269. So you're gonna solve the following inequality. So you're gonna graph the inequality x minus 3y less than or equal to -6. And you're gonna turn into me once you finish that. So that's your assignment for this class work. And we're going to continue the next time with another chapter from your book. So take screenshots of your the problems that you solved for this lecture. Create a PDF file by using PDF scanner or CAM scanner, and submit your file through Canvas. Any question that you have, send me an email indicating the number of the problem, the number of the page, and send me also attach a screenshot of your work.